Hi everybody. So in this video, I'm going to be going through your Chapter 5 Part 2 review and kind of one question at a time, just going through what the answers should be, as well as some common mistakes that we've seen in the past when we've been grading either this assessment or going over this review with students. So hopefully you'll find this helpful in preparation for your summative assessment. So the first problem says the function f has a first derivative given by f prime equals x parentheses x minus 3 squared parentheses x plus 1. And we are asked in part A to find the x coordinate of the critical points of f, and then determine whether this point, it should be these points, are relative minimums, maximums, or neither for f. Justify your answers. So there are really three parts to this question. The first part is to find the x coordinate of the critical points of f. So that's kind of part one. Part two is to determine whether these points are relative minimums. So determine whether we have a relative minimum, a maximum, or neither. And the last part of the question is to justify our answers. So tell us why we know that it's either a min, a max, or neither. Now, the reason I'm pointing this out and breaking this down for you is that this is very typical of an AP style question. So they kind of build multiple parts into one question. And as a result, it can be really easy to forget to answer part of what you've been asked. So what I'm trying to point out to you here is that if we kind of break down the question first before we get started answering, it can help us make sure we don't forget to answer part of the question when we are actually writing our solution. So let's start with what it means to be a critical point. A critical point is a place where f prime of x is equal to 0 or does not exist. Now, in order to figure this out, we need to take the first derivative, which we've already got, and set it equal to 0, or figure out if there are certain x values that would make the first derivative undefined. So on my paper, I'm going to make sure to write down as part of my answer f prime of x equals x parentheses x minus 3 parentheses x minus 3 squared parentheses x plus 1 equals 0. Now you might be wondering, why am I writing this down? The reason is because on the AP test, especially when you're doing the FRQ portion of the AP test, it is really important to show your thinking. So by writing this down, you're demonstrating that you understand what a critical point is to the grader of this exam. So the next step would be to actually solve this equation. To solve this equation, I'm going to break it down into three parts. What is the value that makes x 0? What is the value that makes x minus 3 0? And what is the value that makes x plus 1 0? So I would get three answers: x equals 0, x equals 3, and x equals negative 1. Now, in order to determine whether we have a relative minimum, a maximum, or neither, it is important to make a sign chart. Now, a sign chart does not count as justifying your answer. That's a separate part of the question. This is just how we're going to determine the correct vocabulary word to apply to each of these critical points. So the way that I make a sign chart is I imagine kind of a number line. On a number line, the very beginning is always negative infinity, and the end is always positive infinity. And I'm going to take these critical points, these x values, and line them up in a row in the order that they would go in on a number line. So I would go -1 first, then 0, then 3. Now we need to imagine kind of looking at this number line in chunks. So each of these numbers becomes a section of the number line. What I'm going to do is I'm going to look at the sign of f prime for each of those sections. Now, when I say sign, it means I don't really care about what f prime is actually, what the number is. I just care about whether it's positive or negative. So I'm going to choose a random number between -1 and negative infinity. For example, a random number might be -10. And if I substitute that into the derivative, which I've got right here, -10 times negative squared makes it positive. So this kind of part right here is always going to be positive. So we're going to have a negative times a negative makes it positive, which means the original graph would be going uphill. If I choose a number between 0 and -1, like for example, -1/2, and I plug it in, I'm going to have a negative, and again, a squared is always positive, so positive, and then a positive, and a negative, and a positive, and a positive makes a negative when you multiply. So my original function was going downhill. In between 0 and 3, for example, the number 1, I'd have positive, 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 so the original graph would be going uphill. And if I pick a number bigger than 3, like the number 10, then if I plug that in, I get positive, 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 and I continue to go uphill. Now, based on that information, we kind of visualize this graph. So if we imagine almost connecting the arrows here, right, and then this one just continues to go uphill. If we imagine kind of connecting the arrows here, we can visualize that there would have been a maximum at the -1, and there would have been a minimum at the 0. So this is the part now where we need to justify our answers. So the first thing I would do is I would actually state what I just figured out. So I would say at x equals -1, f of x has a relative maximum. And then I need to say why. Now we're going to use what we just did as our justification. So we would say because f prime of x changes from positive to negative. Now we're going to follow that up by describing what's happening with 0. So we would say at x equals 0, f of x has a relative minimum. And we would say because f prime of x changes from negative to positive. Now, last but not least, one of our critical points was the 3. And at 3, because my function was going uphill and then continued to go the same direction, I would have neither a relative max or a min. So I would say at x equals 3, f of x has neither a maximum or minimum. And I would say because f of x does not change signs. And this is all part of the previous problem. Okay. Now for part B of this question, it says, for what intervals is f decreasing? So let's start by reviewing what it means to be decreasing. Decreasing means your first derivative is less than or equal to 0. In other words, the original function was going downhill. Now, the good news is, based on the work that we already did in part A, we can answer this question using the chart that we already made. So I would say I'm going to be decreasing for this section of the graph. Now, because decreasing is defined as f prime of x is less than or equal to 0, we're going to use closed brackets here. So -1 comma 0 is our answer. And then we would need to justify our answer. So again, justifying your answer means tell me what told you that this was where the function was decreasing. So we would say because f prime of x is less than or equal to 0. Okay, problem number 2. Let h be a function defined for all x's that are not 0, such that h of 4 is -3, and the derivative of h is given by h prime of x equals x squared minus 2 all over x, where x is not equal to 0. For part A, it says, find all the values of x for which the graph of h has a horizontal tangent line. Then determine whether h has a maximum, a minimum, or neither at each of these values. Justify your answers. So let's start with breaking this down into parts. Find all the values of x for which h has a horizontal tangent line. Then determine whether h has a maximum, a minimum, or neither at each of these values. And finally, justify your answer. Now, it turns out that this question is actually very similar to part A of the previous question. What a horizontal tangent line means is that the slope, which is really f prime of x, is equal to 0, because a horizontal line is a line whose slope is 0. So what we're really asking you here is find the places where the slope is 0. Now, the difference between what we asked in problem 1 and what we asked in problem 2 is that a critical point could be a place where the slope is 0 or does not exist, whereas a horizontal tangent line is strictly when the slope is equal to 0. If your slope did not exist, you would not have a horizontal tangent line. So it's kind of narrowing this down to a more specific set of numbers. So let's start with that. First, let's figure out where we have a horizontal tangent line. So we would say h prime of x, which is equal to x squared minus 2 all over x, equals 0. And again, it's really important you show your work here, you show your thinking, because as a grader, either your teacher or an AP grader, we're going to try to see if you understand the concepts. And showing your work helps us determine whether you understand the concepts or not. Now, in order to solve this equation, I would multiply by x on both sides, which really means I still get 0, because anything times 0 is 0. I would add 2, so I would get x squared equals 2, and then I would square root. So x equals plus or minus the square root of 2. So there are 2 places where I have a horizontal tangent line. Now, just like before, we need to figure out whether we have a maximum, minimum, or neither at those values. So again, imagine a number line. The beginning of your number line would be negative infinity, and the end of your number line would be infinity. In between, we're going to place the 2 critical points, or in this case, the places where we have a horizontal tangent line. So be negative root 2 and positive root 2. We're going to use those values to divide up our graph into sections, and we're going to choose numbers for each of these sections and look at the sign of h prime. Again, I don't care about the value, I just care about the sign. So don't overthink this. A number to the left of negative 2, just pick a number like negative 10. Don't try to get too close to negative root 2. I know a lot of people have trouble approximating negative root 2, so don't worry about it. If I take negative 10 and I plug it in, negative 10 squared is 100 minus 2, which makes it positive, divided by negative 10 makes it negative. So my graph would be going downhill. Now, I forgot one thing here, and I do apologize. When we're doing this, in addition to including these 2 points here, I'm going to include the number 0. Now, 0 was not one of my horizontal tangent lines, but it is a place where the slope is undefined. And the reason it's a place where the slope is undefined is that it's a place where the denominator equals 0. The reason I'm including that is that that's going to be a place where the slope can change signs, even though it's not one of the numbers we're going to officially answer as part of this answer. So I apologize. I was going too fast and I didn't stop to think for a second, but that was a good thing to think about. So one thing that I noticed was like, hey, a 0 should really be in here because this is an undefined slope. The slope's going to change signs again. So if I pick a number between 0 and negative root 2, like for example, negative 1, and I plug that in, I'm going to have 1 minus 2 is negative, divided by another negative makes it positive. In between 0 and positive root 2, like positive 1, I'm going to have a negative divided by a positive makes it positive. Makes it negative. And then if I pick a number bigger than root 2, like 10, I'm going to have a positive divided by a positive makes it positive. Now you can kind of see why including that number 0 is really important. If that wasn't there, we would think that this entire section was either going uphill or downhill. We need to make sure to include that 0 because it is a critical point, even though it's not one of the places we have a horizontal tangent line. So last but not least, we need to kind of imagine connecting these arrows. And that helps me visualize that both the negative root 2 and the positive root 2 would be minimums. So I'm going to go ahead and justify my answer. So I would say at x equals plus or minus root 2, h of x has a relative minimum. And we would say because h prime of x changes from negative to positive at those values. Now, if this was the AP test, I would also make sure to really highlight that this is where I have horizontal tangent lines. And I would put a box around this part of my answer, and I would also put a box around this part of my answer because I want my answers to stand out for the graders of the AP test. They don't spend too much time looking at your questions. So if you don't make your answers jump out, chances are they're not going to pay very much attention to what you wrote. All right, part B. On what intervals, if any, is the graph of H concave up? Now, when we're talking about concavity, so concavity is kind of a different ballgame because concavity is the second derivative. So we want to know when the second derivative is greater than 0. Now, in order to make this happen, we're going to have to actually find the second derivative. So the first thing I would do is I would find the second derivative of the function. So h double prime of x equals, now in order to find this second derivative, I'm going to go ahead and I'm going to use quotient rule. So low and then d high, so 2x minus high, so x squared minus 2, d low, which is 1, and low squared, so x squared goes down below. Now I'm going to simplify this, so I'm going to have 2x squared minus x squared plus 2. And the reason I'm getting a plus 2 is that I'm distributing this negative all over x squared. Now 2x squared minus x squared is just 1x squared plus 2 all over x squared. Now I want to know when I'm concave up. So the first thing I need to do is figure out where the second derivative is equal to 0 or does not exist, because those are going to be potential places where my concavity could change. So h double prime of x, which is x squared plus 2 over x squared equals 0, or does not exist. For the equals 0 part, if I multiply by x squared, I get x squared plus 2 equals 0, which means x squared equals negative 2. Now that's never going to happen, so that doesn't give me any solutions. So that's the equals 0 part. For the does not exist part, that would just be when x is 0, because that's what would make the denominator of this equation undefined. It would make the function undefined because the denominator is 0. Last but not least, I would make a sign chart. So just like in my previous problems, I'm going to imagine a number line. Only this time, instead of looking at the sign of h prime, I'm going to be looking at the sign of h double prime. So if I pick a number from 0 to negative infinity, like negative 10, and I plug that in, negative 10 squared is 100, plus 2 is 102, divided by negative 10 squared is 100. So we've got a positive divided by a positive, which means I'm positive, so I'm concave up. In between 0 and infinity, like positive 10, I'm still going to have a positive divided by a positive, so I have concave up. Which means my final answer is going to be h is concave up on negative infinity to 0 and 0 to infinity. And you might be wondering, why don't I just make that negative infinity to infinity? And the reason is because the second derivative is undefined at 0, so I can't include 0. I need to break it up and make two separate intervals. You also might be wondering why I'm using parentheses this time, and it's because the definition of concavity is always a greater than or a less than, and not including the equal to. And I would say because h double prime of x is greater than 0. Okay, let's take a look at page 2. So in these problems on page 2, we're really going to be focusing on given the graph of f prime. Now you're going to notice that in the directions here, it says the figure at the right shows the graph of f prime. It is really important that you know what graph you're looking at because the way you analyze a graph changes depending on whether you're looking at the graph of the first derivative, the graph of the second derivative, or the graph of the original. So in addition to labeling that here in the instructions, you'll also see that usually labeled on the graph somewhere that this is the graph of f prime. It says the graph of f prime has horizontal tangent lines at x equals -3, so that's right here, x equals 2, so that's right here, and x equals 5, so that's right here, and it has a vertical tangent line at 3. Now you'll notice I just kind of drew in little horizontal tangent lines and little vertical lines because that just helps me remember what was in the instructions without having to go back to the directions each time. For part A here, it says, for what values of x does f have a relative maximum or a minimum, and justify your answer. So when does f have a relative max? Separately, when does f have a relative min? And separately, justify your answer. Now, you'll notice that we're given the graph of f prime, but we're asked questions about f, the original. So we have to think about how we can use the graph of f prime to analyze the original. One of the things that we've talked about is that minimums and maximums become x-intercepts. So that tells me that I'm going to have minimums and maximums here at the -5, at the -1, and potentially at the +5. Now, at the -5, my graph changes from positive to negative. So that's going to be a maximum of the original function. At the -1, my graph changes from negative to positive, below to above. So that would be a minimum of the original. And at the 5, my graph does not change signs. So there's going to be neither a min or a max here. It's just a critical point, but not a min or a max. So here's what we're going to do. We're going to list those values. So f has a relative maximum at x equals -5. And our justification would be because f prime of x changes from positive to negative. So that's kind of the first part of the question. The second part of the question says, when does f have a relative minimum? So we would say f has a relative minimum at x equals -1. And we would say because f prime of x changes from negative to positive. Now, one thing I do want to point out is that the reasoning, the because that I used here in this problem is the exact same because that I used here in the first two problems. Because f prime changes from positive to negative. It's how we justify a max or a min. The only difference between these problems is that here we're analyzing our information using an equation that we were given, and in this problem we were using a graph that we were given of the derivative. So it's really important to separate how do we justify from how we do the thinking, because the justification is the same no matter what. It's the way we get to the actual values that might change depending on the given information. For part B, it says identify the intervals on which f double prime is less than 0. So f double prime is the second derivative. If we're looking for the second derivative, we're looking at the slope of f prime of x. So we're trying to think about the derivative, the slope, of the first derivative. In other words, we're trying to find the intervals where this graph has a negative slope. So that would be this interval right here and this interval right here. But this is where I get really kind of the benefit of labeling my graph at the beginning. There was this place here in the middle of this interval where the slope was undefined. There's a vertical tangent line. So when I write my answer here, you're going to notice that I'm using 3 separate intervals. The first interval, the second interval will stop at the 3, and the last interval will pick up again at the 3 and go to the 5. Now, there's also a clue in the directions as to whether I should have open or closed brackets. Do you notice that it says less than and not less than or equal to? That is a clue that for this answer, I should have open brackets everywhere. So I would have the parentheses -7 to -3. Then I would have parentheses 2 to 3. And last, I would have parentheses 3 to 5. So those are the intervals where f double prime has a negative slope, where f double prime is negative because the slope of f prime is negative. Now we're going to justify our answer by saying what it was about this graph that we looked for. So we can do this in 2 ways. Option number 1 is to say the slope of f prime of x is negative. Option number 2 is to say f prime of x is decreasing. Because if you combine the 2 ideas, slope being negative, we can say that with one word, which is decreasing. Here's what you can't do. So a common mistake that I often see is that students say the slope of f prime is decreasing. If you use the word slope and then you also use the word decreasing, it's like saying the word slope twice, which means instead of looking at the second derivative, you're going 2 derivatives further, which is the third derivative, which we almost never care about. So you can't mix and match here. You're either allowed to say the slope of f prime is negative, or you're allowed to say f prime is decreasing, but you cannot say the slope of f prime is decreasing. The other common mistake that I see is that students want to say the slope of the graph is negative. You can never use pronouns in your justification. You can never just say it or the graph. You need to be specific in your references. You need to say f prime of x because that's the graph that you're given. So it's really important to be meticulous about the way you're justifying your answers here. For problem number 4, it says the figure at the right shows the graph of f prime. So again, we're looking at the graph of the derivative. It's labeled in 2 places because they're really hoping you notice that this is the derivative. The domain of f is the set of all real numbers between -3 and 5. For part A, it says, for what values of x does f have a relative maximum, a minimum, and justify your answer? So you'll notice this is a very similar question to the one we just did. First, we're trying to figure out where does the original graph have a maximum. Then we're trying to figure out where does the original graph have a minimum. And last but not least, we're trying to justify our answers. So again, if we're talking about the original, but we're looking at the derivative, we're going to be looking for maximums and minimums at the places where we see x-intercepts. The first place here is going to be at -2. So at this place, the graph of f prime changes from positive to negative, so that's going to be a maximum of the original. Even though the +1 is an x-intercept, it's going to have neither a relative max or a relative min because it does not change signs. The graph stays negative on both sides. And last but not least, at the +4, we're changing from negative to positive, which means we have a minimum on our original graph. So we're going to go ahead and justify our answer. So we're going to say f has a relative maximum at x equals -2, and we would say because f prime of x changes from positive to negative. Now, the second part of this question says, where does f have a relative minimum? So we would say f has a relative minimum at x equals 4, and we would say because f prime of x changes from negative to positive. Now for part B, it says, for what values of x is the graph of f concave up? So in order to figure out where my graph is concave up, I'm going to be looking for where the second derivative is greater than 0. Now, the second derivative is the slope of f prime. So in other words, for this graph, I'm looking for where the graph is going uphill. So I'm going to use this section of the graph and this section of the graph, which means my answer here would be negative 1, 1 and 3, 5. And I would say because, and again, here is where I need to justify my answer. I have two choices here. I can say because for option number 1, the slope of f prime of x is positive. Or I could say because f prime of x is increasing. But just like before, you can't mix and match. So you can't squish together slope of f prime of x is increasing. You can't switch the words back and forth. So kind of pick which one makes more sense to you and stick with that one all the time. So if I'm somebody who feels like, you know what, I like to say the slope of f prime of x is positive, I might also say the slope of f prime of x is negative, and I'm going to say it the same way every time I practice so that I don't make a mistake in the future. All right, I'm going to stop there for this video, and I will pick up in the next video starting with problem 5.